Good afternoon.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
तो यूनिट टू तो पूरा खत्म हो गया। तो आज यूनिट थ्री नहीं, यूनिट फोर पहले मैं शुरू करूँगा, फिर यूनिट फोर के बाद यूनिट थ्री स्टार्ट होगा। तो यूनिट फोर में है सीरीज सीक्वेंस। ओके, so we're going to start unit 4. यूनिट 4 इसमें पहले क्या है, सीक्वेंस। So first we have to know what is sequence. A sequence is a succession of numbers or terms formed according to some definite rules. So a sequence is a succession of numbers or terms formed according to some definite rules. That means the numbers or members of the sequence must follow some rules. The nth term in the sequence is denoted by un, and the sequence is denoted as second bracket. This is a sequence. That means there are some numbers or terms. Which terms? u1, u2, u3, u4, and up to infinity. Infinite numbers, suppose let an example, let un equal to 2n plus 1. So this is the rules, this is the definite rules for the sequence un. So the first term will be for n equal to 1, that means first term is equal to 3. Second term u2 will be 5, u3 equal to 7. If the sequence have unlimited numbers, then sequence will be called infinite sequence. If a sequence having unlimited or infinite number of terms, unlimited or infinite number of terms, then the sequence is known as infinite sequence. Limit of a sequence. Limit of a sequence. If a sequence tends to a limit, if a sequence tends to a limit L, then we can write limit n tending to infinity sequence un equal to L. Suppose we have a sequence 1, 2, 3, infinity. The limit of this sequence will be what? Limit of the sequence what? Infinity, because un as n tends to infinity, un equal to n. So limit n tending to infinity un, that will be infinity. So limit of this sequence is infinite number, infinity. And suppose we have the sequence 1, 1 by 2, 1 by 3, and so on. In that case, limit will be what?
0.
In that case, limit will be 0, right? Because un is equal to 1 by n. So limit n tending to infinity, un is limit n tending to infinity 1 by n, that is 0. So limit will be 0. Now convergent and divergent sequence. Convergent and divergent sequence. If the limit of a sequence is finite number, then sequence is convergent. If the limit of a sequence is finite, the sequence will be convergent sequence. And if the limit of the sequence does not tend to a finite number, if the limit of a sequence is not finite, that means the sequence will be called divergent sequence. So suppose sequence 1, 1 by 4, 1 by 9, 1 by 16, 1 by n squared. This will be a convergent sequence. Convergent sequence because the limit L is equal to 0, and the limit, suppose the limit sequence 3, 5, 7, 2n plus 1. This limit will be infinity. So this is a divergent sequence because L is equal to infinity. And what will be the limit of this sequence? 1 plus
1.
1.
yes, because this limit is 1 plus 1 by 1, 1 plus 1 by 2, 1 plus 1 by 3, and so on, 1 plus 1 by n. As n tends to infinity, the limit is 1 by 1 plus 0, that is limit. limit is 1. So this is a convergence sequence. Next, bounded sequence. Bounded sequence. What is bounded sequence? If a sequence, suppose u1, u2, un is bounded sequence if un less than k is a constant, un less than k for all n, then sequence will be bounded sequence. Un less than k is a positive number for all n, then the sequence will be called bounded sequence. Now say this. Is this a bounded sequence? One plus 1 by n is a bounded sequence.
Yes,
Yes,
sir.
sir.
Yes, because all the number of the sequence less than equal to 2 or less than 2. Or you can say this is less than 3. So there is a number, positive number k, all the member is less than k. Now, sequence n. Is it a bounded sequence?
No, sir.
No, sir.
No, sir.
Yes.
No, sir.
Okay. Now, monotone sequence. Monotone sequence. If a sequence is either increasing or decreasing, such a sequence are called monotone sequence. Either increasing or decreasing, then the sequence is called monotone sequence. So 1, 4, 7, this sequence is monotone increasing, so this is a monotone sequence. This is monotonically increasing, so monotone sequence. And 1 half, 1 by 4, this is monotonically decreasing sequence, so this is also a monotone sequence. But suppose we have a sequence 1, second term is -1, third term is 1, fourth term is -1, like this, because this is a sequence of -1 to the power n. Is this a monotone sequence? This is not a monotone sequence because it is not increasing, not decreasing. This is actually oscillates. So this is not a monotone sequence. No. There is a theorem. Theorem is a sequence which is monotonic and bounded is always a convergent sequence. Is always a convergent sequence. A sequence which is monotonic and bounded, then the sequence will be always a convergent sequence. Monotonically increasing, yes, monotone and bounded, this is called a convergent sequence. Now, suppose examine the following sequence for convergence. Examine Example 1. Examine the following sequences for convergence. The sequence is given an equal to n square minus 2n 3n square plus n. This is your sequence an. We have to check the limit. So limit n tending to infinity an. So limit n tending to infinity n square minus 2n 3n square plus n infinity divide 1 by n square, that
1 by 3, sir.
right,
1 by 3
2 by n
sir.
and 3
1 by
plus
3.
n by n square. So this will be limit 1 minus, so 1 minus 2 by n, this limit is 0 because n tends to infinity is 0, and this is 3 plus 0, so limit is 1 by 3. 1 by 3, that means a finite number. So this means this is a convergent sequence. Now second one, example 2, an equal to 2 to the power n. The limit n tending to infinity, an will be what? 2 to the power infinity, that's a infinity. This means this is a divergent sequence. Third one is an equal to 3 plus minus 1 to the power n. So limit n tending to infinity, n will be what? What? 4
Sir,
and
1, sir. 1.
1, no. 4
Sir,
and
वो
1.
डिपेंड करेगा ना, यूनिट
Different.
की वैल्यू पर डिपेंड.
When n is, yes, n is
It
even,
will not be
n is odd.
yes, and n is, when n is odd, then the limit is 2. That means this limit does not have a unique limit. So this means this is not a convergent, not a divergent sequence. This is a oscillatory sequence. Oscillatory sequence, not convergent, not divergent. This is a oscillatory sequence because there exists there does not exist a unique limit. Now, series. A series is actually the sum of the members of sequence. A series is the sum of a sequence, that is members of sequence. Let u1, u2, un, this is a given sequence. Then the expression u1 plus u2 plus un dot, this expression is called the series. It's called the series associated with this sequence. Associated with the given sequence. So this is a sequence. Sequence is the series. Series is the sum of the sequence. Now, if the number of terms in the series is limited, if the number of term of a series is limited, that is finite, then series will be called a finite series. And when the number of the series is unlimited, when the number of the term of a series is unlimited, then the series will be called a infinite series. Infinite series. And series is denoted by n equal to 1 to infinity for infinite series un, or summation un for infinite series. Notation of a series. The sum of the first n terms of a series is denoted by Sn. So what is Sn? Sn is equal to u1 plus u2 plus un. The sum of the first n term of a series is denoted by Sn. Now convergent series, divergent series. Convergent and divergent series. Consider the series un, or un equal to u1 plus u2 un up to infinity, and Sn is the sum of the first n term, that is u1 plus u2 un. Then if Sn tends to a finite number as n tends to infinity, then the series un is said to be convergent. Un is convergent. Second one, un tends to infinity as n tends to infinity, then the series un is divergent. And third one is, if Sn does not tend to a unique limit, Sn does not tend to a unique limit. Say limit may be finite or infinite, then series will be called, oscillatory series. Now property of infinite series. the nature of an infinite series does not change if by multiplying all the terms by a constant k, by multiplying of all the terms by a constant k. If we multiply by a constant term k, the nature of the infinite series does not change. And the second one is by adding or deleting of a finite terms, the nature of the infinite series does not change. That means suppose we have a sequence right. Giving an example. Suppose this is -10, -6, -1, 5, 12. Okay, series. It is a series. -10, -6, -1, +5, +12, +22, and this is. Suppose we delete these first three terms. If we delete the first three terms, then the nature of this series, this is not series, sequence, this is a series. Suppose un. The nature of the series un does not change. If we delete the first three terms, the nature of the series does not change. Now there is another also property. If two series un and vn both are convergent series, then un plus gn is also convergent. If un and series un and vn both are convergent, then un plus vn, this series also convergent. Some example. Series. Find the nature of the series 1 plus 2 plus 3 4 up to n and infinity. So we have to find the nature of the series. So first find Sn. Sn is sum up to nth term. So is n plus 1 by 2. Now find the limit. Limit n tend to infinity Sn. N into n plus 1 by 2. This will be infinity. So this series is divergent. Divergent series. Second example 2. Test the convergence of the series 1/2, 1/4, 1/8, up to infinity. So Sn is equal to 1/2 this term up to this. Now actually as n tends to infinity, as n tends to infinity, as n tends to infinity,
So Sn equal to a upon 1 minus r be applied.
actually this is a
GP in GP.
this is as n tends to infinity. This is a series. This and sum of the series is 1 by r na, when r less than half. So this is 1 by r. Here r is equal to when r less than 1 actually. This r less than 1. Here r equal to half. This is 1 by 1 minus half. So this is 2. That means
सर
हाँ बोलो.
सर वहाँ पे 1/2 होगा
हाँ
वहाँ ऊपर में.
In Sn equal to 1 plus 1 by half plus 1 by 4 plus 1 by 8. So 1 upon 2 to power n. Yes, sir.
2 to the power n ना.
Yes sir.
Yes. 2 to the power n. Right. So Sn is equal to, as n tends to infinity, Sn equal to 2. That means a finite number. Finite number. That means the series is convergent. That means series is convergent. Now, example 3. 2 by factorial 3, 3 by factorial 4, 4 by factorial 5. This is the series. So first find the term un. So un will be this is u1, this is u2, and this is u3. So u1 equal to 2. So un equal to actually n plus 1 by n plus 2 factorial, right? So un we can write n plus 2 minus 1 n plus 2 factorial, n plus 2 factorial. That means this is n plus 1 factorial, 1 by n plus 1 factorial minus 2 factorial. So Sn equal to what? u1 plus u2 plus dot un. So first find u1. u1 equal to 1 by 2 factorial minus 1 by 3 factorial. u2 equal to 1 by 3 factorial minus 1 by 4 factorial. u3 equal to 1 by 4, 1 by 5 factorial. And un is equal to 1 by what? N plus 1 factorial minus 1 plus 2 factorial. If we add these terms, then we get Sn, and this cancel. 1 by factorial 3, this 1 by minus factorial 4, 1 by factorial 4, 1 by factorial 5, and here will be 1 by factorial 5, and there is minus 1 by 1 plus n factorial, plus 1 by 1 plus n factorial. Then we get actually 1 by factorial 2 minus this, and this will be 1 by 2. How?
N tends to infinity.
And n tends to infinity. As n tends to infinity, 1 by factorial 2 by 1 by 0,
1 by
right? 1 by 2. So the limit is finite. That means the limit is finite, and we can say that the series un is convergent, and the limit is half. Example 4. Discuss the nature of the series 2 minus 2 plus 2 minus 2 plus 2 minus 2, like that up to infinity. So what is Sn? Sn will be 0 when n is even, and plus 2 when n odd. That means Sn does not tend to a unique limit. That means Sn does not tend to a unique limit. Therefore, the given series is oscillatory. ओके ठीक है, बस आज का यही था. नेक्स्ट डे कॉचीज थ्योरम है, डाइवर्जेंस, नेसेसरी एंड सफिशिएंट कंडीशन फॉर कन्वर्जेंट डाइवर्जेंस, वो सब पढ़ेंगे नेक्स्ट डे. आज के ही तक, ठीक है.
Thank you, sir.
थैंक यू.
Thank you, sir.
Thank you, sir.